All right, everybody, it's good to see you in another video. Well, in this video, we're going to talk about and solve some important questions regarding to the chapter 4 and especially logarithm. So, and like particularly the properties of logarithm, how are we going to use to solve questions, to solve equations, and how are we going to simplify like some expressions that they include logarithm or exponential functions. Just stay with me, let's just go through them. All right, the first question, solve the following equations. So we have got equations here. The first one, there are like two logarithm equals to 0, but there is negative between them. So when there is negative, it means that we need to turn these two logarithm in one logarithm and divide these exponent by each other, because the property says that if there is negative between two logarithm, we need to divide the exponent of them. All right, how are we going to do it, Mr. Rahman? So let's just say that, okay, log, just maximize the size. All right, perfect. So the exponent of this one is a quadratic function, which is x squared minus 2x plus 18. So x squared minus 2x plus 18 over because of the property. So over what? Over the exponent of here, which is x. And the base for both of them is 5. We are not going to change this base. Equals to 0. Then the famous rule that we already discussed about it, right hand rule. It says that 5 powered by 0 equals to that. So 5 powered by 0, everybody know that it equals to 1, because number powered by 0 equals to 1. Equals to x squared minus 2x plus 18 over x. Right now, let's just find out what we need to do here. So give a denominator of 1 to here, and then the famous cross product theorem. All right, method we can say. 5 powered by 0, it equals to 1. You know that, right? 1 over 1. So right now, cross product. 1 times x, it equals to x. 1 times this expression, it equals to itself. Minus 2x plus 18. We know that we need to whenever we have quadratic equation, one side must become 0. So move this x to the other side, it's going to become negative, right? So negative x. Now negative 2x, so negative 1x equals to negative 3x. So finally we are going to have x squared minus 3x plus 18 equals to 0. A quadratic equation. What is A? 1. B is negative 3. C is 18. The formula, the quadratic formula says that x equals to negative b plus minus square root of b squared minus 4ac over 2a equals to negative b, negative 3, it equals to 3, plus minus square root of b squared equals to 9 minus 4 times 1, 4 times 18, 72. Over 2. Right now, take a look at the under of this square root, inside of this square root. So 9 minus 72, it's going to give us a negative result. Since inside here is negative 63, so we are going to say that we have got no solution for this equation. All right? If it was positive, so we have got solution. If it is 0, we have got one solution. And if it is negative, we have no solution. So stop over here. You don't need to just go on. That is the result of this equation. How about the second one? So I hope that you understand it. If you not, just repeat it and look at it again. This question. Noor. 3 powered by 6x equals to 17. My question is, can we write 17 as a power of 3? Absolutely not. It's not 9. It is not, for instance, 27 or a number that can be written as a power of 3. That's why even in my previous video, in the first lesson regarding to logarithm, section 4.4, I said that if we couldn't find out if we couldn't write down like one side in terms of the other side, we need to use logarithm. Take logarithm for both sides. Noor. AY, okay, take log for both sides. Of course, when we take log, we should think about its base as well. So for such a question, Danas, we said that the base must be equal to the same number that we have it here. So what number do I have here? 70. So the base must be 70. So right now there was a property that it said if the exponent and the base are the same thing, logarithm equals to 1. So right now let's just rewrite this one. Log 3 powered by 6x base 17 equals to 1. Now, as well as we had a property that it says that if there is an exponent, that exponent comes behind the logarithm. So we can write it in this way, 6x log 317 equals to 1. Now, in order to find x and make x alone, we need to divide both sides by whatever stand with x. So what do I have here with x? I have got 6, I have a logarithm as well. So 17, and divide the other side exactly by the same thing. So 6 log 370. That's going to cancel everything here. And what will remain? X. This is exactly what we are looking for. X equals to 1 over 6 log 3 with base 17. That is the final result. One more question here. Regarding to logarithm, again we have got negative. So for negative, we need to turn it to division. We need to divide the exponent. So 1 log, don't change the base, 3, 5x plus 8 over x equals to log 9 base 3. Now we are just going to cancel out something. So bases are going to cancel each other. Logs will cancel each other. So this exponent must be the same with this exponent. So equalize them. 5x plus 8 over x equals to 9. Give a denominator of 1. Cross product. X times 9, 9x. 1 times 5x plus 8, it's equal to itself. Right now, this 5x must come to the 9x. Why? Because it is smaller. So always we say that in equation, when we have got more than one term of a variable, always move the smaller one to the bigger one. So 5x and 9x, which one is smaller? According to Noor, it's 9x, but in fact, 5x is smaller than 9x. So this 5x is going to come here. So 9x, of course, when you change the side, the sign will change. Minus 5x equals to 8. 9x minus 5x, 4x equals to 8. Now, Danas, divide both sides by 4. Divided by 4, x equals to? This is the single solution that we have got for this equation. Pasha Noor? Perfect. One more question here. That is a beautiful question here. 3 powered by 6x minus 1 equals to 70. Can we write 70 in terms of 3? Absolutely not. So we need to take logarithm. But before taking logarithm, there is one more step that we need to do for such a question. So remember here, we studied something like this. A powered by m minus n. So it can be written as a powered by m over a powered by n. That is what we call technology. All right, so we had that note, we studied it in previous grades, whenever we have got a powered by m minus n. So in fact, it is a powered by m over a powered by n. We can use that note in this question before taking logarithm for both sides. Let's just use this one. So our m, it's 6x, our n is 1. So let's say, okay, 3 powered by 6x over 3 powered by 1, which is 3. No need to write 3 powered by 1. Equals to 70. Right now, do a cross product for me, please. 1 times 3 powered by 6x, 3 powered by 6x. 3 times 17, 51. Now take logarithm. Take logarithm for both sides. Log. With what base? Base should be equals to this number, 51. In order to cancel this side. 51. So this is going to become 1. Now log 3 powered by 6x base 51 equals to 1. 6x can come behind the log. So it's going to become 6x log 351 equals to 1. Divide both sides by whatever is with x. What do I have with x? I have got 6 and log 351. 6 log 351. So finally the answer is x equals to 1 over 6 log 351. Okay. The last one, we have got e powered by 5x minus 15. You might say that, teacher, it looks like the previous one. But since there is e, so we can just say that there is an easier way. All right, what is the easier way? We know that e and ln are inverse of each other. So instead of taking logarithm, take ln for both sides. If we take ln for here and ln for here, in the beginning of the section 4.4, we just explained this, that ln and e, whenever they reach each other, they are going to cancel each other out. So what will remain? 5x minus 15, as well as we studied that ln1 equals to 0. So right now, negative 15 is going to come here. 5x equals to 15. Divided by 5, divided by 5. This 5 is going to cancel this one. 15 over 5. X equals to? Noor is saying that 4, but in fact it's 3. Okay, don't listen to Noor. Perfect. That was about how to solve equations, like some important questions regarding to logarithm and ln, of course. We have got some more questions regarding, but this time about simplifying. How are we going to simplify this equation, these expressions? Logarithm 72 base 6 plus logarithm 2 with base 6. Again, I'm going to say that. Take a look at both logarithms. See which one can be simplified and which one cannot be. For instance, we can't do anything with here. Alright, so basically you can say that, alright, so 72 can be written as logarithm 36 times 2 base 6. Can it? Of course it can. Plus logarithm 2 base 6. Now, we can separate this one. There is multiplication, so this multiplication is going to turn to addition. So log 36 base 6 plus log 2 base 6, and originally we have got log 2 6. Log 2 6. These two are the same thing. So 1 plus 1, 2. So we are going to have 2 log 2 6. How about 36? So 36, everybody know that it can be written as 6 powered by 2. If the base and exponent are the same thing, so the logarithm equals to these exponents here. Right? Which is 2. There is an easier way. Actually not easy. Let's just stay away from the second way. This one is the common way that we can use it. Alright? Try to simplify one of those numbers that can be simplified. And always try to look for a perfect square numbers. Right now, some of you behind the camera might say that, teacher, is 72 can be written as 8 times 9. Tamam. I did not say that it is wrong. But it takes like more steps to simplify it, to solve it. Or some others can say that, okay, 72 also can be written as 6 times 12. Yes, go ahead. You will, at the end, you will definitely get the same thing. But whenever you have got a perfect square factors, why don't you want to use it? Because perfect squares are always going to make the things easier. Okay, let's go for the next one. Bash. 54, log 54 with base 3 minus 5 logarithm 2 with base 3. Always take a look at the base. Right now, can we simplify 2? Absolutely not. 2 what? To nothing else. So 2 can be written in one way. 1 times 2. So you are not going to do anything with it. You cannot do anything with it. But 54, yes, it can be written in different ways. But the best way is, if you change 54 to 27 times 2, that's going to help us to simplify it in the easiest way. Otherwise, 54 can be written as 6 times 9. So you can just go on in that way as well. All right? That's it. 4 times 10, 4 times 4. No, that's it. So either 6 times 9 or 27 times 2. So 27 times 2 is the best way, because 27 can help us, and you will see how. So since there is multiplication again, separate them. Logarithm 27, don't change the base. Base is 3 plus logarithm 2 base 3. And originally we have got negative 5 logarithm 2 base 3. So right now, I want you to just calculate this one before I do. Right now, these two logarithms are the same thing. The coefficient of here is 1. The coefficient of here is negative 5. 1 minus 5 equals to what? Negative 4. So it equals to negative 4 log 2 with base 3. How about 27? 27 can be written as 3 powered by 3. Then the base is the same. The bases are the same thing, so the result equals to this exponent over here, which is 3. In another word, we can say that this is a property. Logarithm 3 powered by 3 with base 3. Our 3 can come here. So 3 log 3 with base 3. This one equals to 1, right, Noor? 3 times 1? 3. That is the result of this one. And of course, in the next one, the story is easy. ln and e are going to cancel each other out. What will remain? Square root of x. Does it work? Oh, I thought that it's not. Alright, so ln and e, they're going to cancel each other out. So only what will remain? Square root of x. That's it. How about here? So right now, remember the notes of m over n. I gave you logarithm a powered by m, a powered by n equals to m over n. So right now turn these two to like power of 10. Yani what and how? Logarithm. 10,000 equals to what? Or we can say that 10,000 is equal to 100 powered by 2. Go and check it. 100 powered by 2 equals to 10,000. And here we have got 100 powered by 1. When there is no power, power is 1. So right now, look, the bases are the same thing. A, so our A is 100. So the result equals to m over n, which is 2 over 1. Finally 2. Any problem? I'm pretty sure you don't have any problem, but there are some beautiful students here. Just want to make sure that they have or not. Alright. Even if they have, I'm not going to fix it. They can just watch the video at home. Alright, the next one. Logarithm 1 over 64, base 1 over 2. No, simply you can say that log 1 over 2 powered by 6. Go and check it. 64 is 2 powered by 6. And the base is what? 1 over 2. These two are the same thing. So the result equals to 6. There is this property, no, logarithm a powered by n base a equals to n. Basha, how about this property? This one. It says if this base is the same with this base, so the result equals to the exponent of the logarithm, which is 5x. One more example for Danas. So imagine Danas, we have got 3 log 0.5x squared base 3. If these two bases, the base of the expression and the base of the logarithm were the same thing, so the result equals to this exponent of the logarithm, which is 0.5x squared. Alright? Perfect. How many minutes it says? How long it is right now? The video? 20. That's enough, I guess. I don't want to just make it longer because these type of questions are also possible to come. Find the inverse. Alright? If the points, these given points are on the function f, then find the inverse function. So inverse function's notation was f powered by negative 1. We said that to find f inverse, just switch the place of x and y. right? So here negative 1 and 0 will become 0 and negative 1. 0, 4 will become 4 and 0. 2 and 7 will become 7 and 2. 3 and 10 will become 10 and 3. Right? There is the coordinate plane over here. Alright, the first one, it says graph both of f and its inverse. Yani we need to graph f and f inverse. So the f is are these points. Negative 1 and 0 is here. That is negative 1 and 0. 0 and 4, here is 0, 4 is here, let's say. 2 and 7, so if here is 1, 2 here. So 2 and, let's imagine 7 is over there. And finally we have 3 and 10. 3 and just let's imagine here is 10. So join these points, it's gonna give you the graph of f. Something like this is enough for me. And how about the f inverse? Note 0 and negative 1. 0 means no left, no right. Negative 1 goes down 1 unit. So here is the point. 0 and negative 1. 4 and 0. 4, 1, 2, 3. Let's imagine 4 is here. 4 and 0 is over here. 7 and 2. We don't have enough space, so let's just make here 7. 7 and 2. 2 is here. So the point is going to almost be here, because of not having enough space. So how about 10 and 3? So 10, imagine here is 10. Right? 10 is over there, and for 10 we have got 3, so 3 is over here. All right, the point, the graph would be something like this. That is the graph of f inverse. Here is the graph of f. Got it? Inshallah you got it. Something else that it is important here is converting. Convert each exponential function to logarithm form. We actually discussed about this matter in the beginning of section 4.3. Convert exponential to logarithm and logarithm to exponential. Alright, so I'm going to do one of them here and this one here. Because if you get this one, we're going to learn it. You're going to solve the rest by yourself easily. So square root of 2 powered by x equals to y. It says turn each exponential to logarithm form. So we need to write log first. The base is square root of 2, so the base doesn't change. Exponent here is x, so that exponent will become the result. And the result here is y, so that y will become the exponent of the logarithm. Try the others exactly in the same way. How about what if we have logarithm and wanted to turn it to the exponential form? Use right hand rule. Right hand rule. So here we have got logarithm xy equals to 3z. So we are going to say that y powered by here equals to here. Yani y powered by 3z equals to x. That is the exponential form of this logarithmic form. Got it? Use right hand rule. Y powered by 3z equals to x. Any more questions? Let me see, left or not? No more questions. So that was a kind of like worksheet that I believed it was important. I hope guys that these videos are beneficial for you and you got a lot of benefit from them. See you in another video. Take care.